Hello guys, welcome back to MathZone African Motives, still on our mathematics N6, and this is partial fractions. We have a part that is very crucial in our workings, which is the part of partial fraction. Just like our N5, we had this part of integration using with the use of or with the help of the partial fractions. We talked about this. So what you're going to have, okay, this is a November 2022 exam. So I'm just going to explain this part before we have our question. What you need to understand is that these are the presentations of your partial fractions, right? Talk of a condition whereby we have got a repeated linear expression. So this one is a linear ax plus b, it's a linear. So it's repeating, all right, raised to an exponent of n, whether it's 2, 3, whatever that you're given. So it's going to be a over that linear expression, ax plus b plus ax plus b squared up to the exponent of n, which is the last part, up to the last part, which is the exponent. So if it is to the exponent of 3, you have to expand up to the exponent of 3, like this, all right? If it is to the exponent of 2, we have to expand corresponding up to 2, depending with the exponent that you're given here. So what it means is that with this information, if we take it like this, because this is a linear, and this is a linear, but it's a repeated because it's raised to the exponent of 3. So using this idea, we are going to raise this ax plus b up to the exponent of 3, ax plus b squared, ax plus b to the exponent of 3. We are done for ax plus b. For cx plus d to the exponent of 3, we do the same. We start with cx plus d squared up to 3. So that is the whole idea that you work out this, all right? So that's for a repeated, okay? We know our linear from our N5, we talked about the linear, so I'm not gonna waste much time of the linear where we are given f of x over ax plus b. That was our N5, all right? Into cx into cx plus d. When we are given a linear like this is not like a repeated, it's different. So this gives us, remember, a over the first bracket, ax plus b, plus b over the second bracket, which is cx plus d. Remember our N5, right? So here the extended part that we just have now in N6 is this, having this, of which we had a quadratic in N5, isn't it? Yeah, we had that. So the last part, we've got a quadratic, this ax squared plus bx plus c. This is a quadratic expression that cannot be factorized. It's a quadratic expression that cannot be factorized. So this cannot be factorized, cannot be factorized. If it can be factorized, it means it's a linear. If it can be factorized, therefore, it gives us f of x over ax plus b, that one that we wrote before, into cx plus d. If it can be factorized, we know that we're going to have 2 brackets for a quadratic. But this one that is written like this, it means it cannot be factorized. That's why they wrote it like this. So for any quadratic expression that cannot be factorized, any that cannot be factorized, that is where you apply this. Ax plus the next term, in actual sense here, let's say we do not have this for this linear. This is for the repeated linear. I'm not going to talk about this. So let's say we're talking about, it's going to be ax plus b like this, all right, over that quadratic expression. So it's ax plus b. The next term is going to be c, d, e, and so on. We have used ax plus b, so the other terms c, d, and so on, so that we do not have a confusion. But on your formula sheet, it's given like this. It's fine, but we're supposed to have it that way that I'm explaining. Ax plus b, then this one will be your c, all right? This one will be your d, and so on up to the last term. So with this idea, or with this, our extended part of the quadratic, I'm going to explain if we have that. But in most cases, you see that you go back to your N5 as it was. It's only that in N5, we just did like, we didn't talk about this in deep detail. We just like had those basic questions. All right, so this is it. We are given to integrate. All right, this is our first question, integrate with respect to x, which is 3.1. Okay, let us just save it here. We are supposed to integrate with respect to x, x cubed plus 6x minus 7, everything over the bracket of x squared minus 2x minus 3 squared with respect to x. And also remember, with our partial fractions, the numerator is always supposed to have the lesser exponent. If we are given x over x squared plus 3, it is called a proper fraction. The x that we have on the numerator, it has a lesser power than the denominator. But if we have a higher power in the numerator like this is now called an improper fraction. So this one, it's a proper, we are used to this. This one is now an improper fraction the moment we have a higher exponent in the numerator. So if we have a higher exponent in the numerator, we perform long division, our long division that we had in our N5. So we have to check for this first. Do we have a proper or an improper fraction? So if we check here, this is a proper fraction. Why? Yes, we can see that there's an exponent of 3 here. So someone will be asking, here there's an exponent of 2. It's true that there's an exponent of 2, but take note, there's also an exponent of 2. Remember, if you expand a quadratic, x squared, if multiplied to another x squared, it is going to give us x to the exponent of 4. So it means the denominator, it has a higher exponent. It has x to the exponent of 4. So this one, it's a normal fraction. It's a proper fraction. There is no long division to be done. We just have to expand this into 2 fractions, then we integrate. All right, how do we do this? Okay, so we are going to talk about we're just going to focus on what is inside of the integral. All right, so you're just going to let this, or just simplify this part that is inside of the integral, this, all right, which is x cubed plus 6x minus 7 over x squared minus 2x minus 3 to the exponent of 2. It is going to be equal to what? All right, it is raised to the exponent of 2. So we are talking about a condition of a repeated linear, the one that I showed you guys on the first part. Okay, let me go back to them. This part and show you again. We are talking about this repeated linear where it is given to the exponent of n. So it's going to be a over ax plus b, which is the linear, ax plus b squared, ax plus to the x, depending with the exponent, you expand up to the exponent that you are given here. If it is 3, you expand up to 3. This is n, so we expand up to n. So this is what we exactly have on our question. It is being raised to the exponent of 2. Okay, let us get back to our question and see what I'm trying to explain here. All right, if we take this, it is being raised to the exponent of 2. So that means we are working with a repeated linear. So we are going to expand this as a over what is, if we are not saying like it's a repeated linear on its own, but it's a quadratic that is being repeated. So we are going to have this either in 2 brackets. All right, so we are going to have this as x squared minus 2x minus 3 like this, okay, plus b over x squared minus 2x minus 3 squared. This is what you're supposed to have in actual sense. But the question is, what is this x squared, this part that I'm talking, what is it representing? Yes, it's a quadratic, but can we not factorize? We can factorize this or not. That is what we have to try, so that we do not write in form of this nature of a quadratic, right? I want us to be clear there. We need to have a linear. So we're going to factorize this and see. All right, x squared minus 2x minus 3, this is a linear. So you're going to try to have, this is a quadratic. So the coefficient of x squared, it's 1. So meaning to say we're going to have 2 brackets, x and x. We try our factorization. Do we have factors of -3, remember your factorization, and 3. Factors of -3, but these factors should add up to -2. Yes, we have got factors -3. If we consider the factors of -3, we've got -3 and a 1. All right, if we multiply these two numbers, we get -3, which is this one. If we add these two numbers, we get -2. So these are the two numbers that I need, -3 here and a positive 1. So you're going to have a positive 1 like that. Okay, so what does it mean here in actual sense? What it means is that we are having this part here factorized as, this is what you're going to have, A over the bracket. So in actual sense, we're going to have two brackets. So to avoid that, guys, let's do this, all right? Because yeah, I'm going to confuse you. I'm going to confuse you for the rest of your life if I do this. So let me not do that. So let me write this way. X cubed plus 6x minus 7 over this being factorized, which gave us these two brackets, all right? This one is not going to have any confusion in your life. You're going to understand this, x plus 1 like this. But the whole of this part is being what? Is being squared like this, okay? It is being squared. The whole of this part is being squared. So if it is being squared, what it means is that this is going to be raised to the exponent of 2. Also, x plus 1 is going to be raised to the exponent of 2 from our laws of exponents. So that will be x to the exponent of 3 plus 6x minus 7 over this part, which is going to be x minus 3 squared into x plus 1 squared. Okay, now I hope at this stage we won't have confusion. Okay, at this stage, we can properly separate to say this here is being raised to the exponent of what? Of 2. The next term also is being raised to the exponent of 2. Okay, so considering what we talked about in the previous case, we said for any repeated linear like this, we are going to expand it, starting with what we have, like we're going to start with a over x minus 3. So it's going to be the way this part here, or let us just expand it on this side. I still have space here. So let me utilize this space here. All right. So we're going to expand this as it is equal to, all right, first bracket of x minus 3, depending with the order that you written. Maybe you started with x plus 1. It depends with how you presented your way here. Okay, so having x minus 3 as our first bracket, we're going to start with a over x minus 3, which is our first linear, up to the exponent of, it is up to the exponent of 2. So it will be plus b over x minus 3 squared. So that is the idea there. If it was to the exponent of 3, we were going to have another term like c over x minus 3 to the exponent of 3. All right? But we do not have that term. So we're not going to do that. All right? So we're not going to have this as to the exponent of 3 because it's to the exponent of 2. If it was to the exponent of 5, you expand up to the exponent of 5. So this was going to be 3, 4, 5, and so on and so on. So we are done with this part. We move to the bracket of x plus 1. So this is going to be plus c over the bracket of x plus 1. So that is x plus 1. Okay, or you can just leave it like that. Plus, we move on to the next term, which is d over, it started as x plus 1. So the next term is increasing. So it's x plus 1 squared. So it's like we've got x plus 1 to the exponent of 1, x plus 1 to the exponent of 2, and so on, up to the last term, which is the exponent that you're given. So if the whole of this part that we see here gives us this, if this part is equal to this, let us get back to our normal simplification that we had back in our N5. How will we simplify? We're saying we are going to take the numerators now, the numerator of this fraction that we are equating to the separated fractions on this side. So the numerator there is x cubed. So it means we're going to have x cubed plus 6x minus 7 is equal to the numerator of this part, which is a, all right? So it's going to be a into, now we divide. So if we cancel this, there is x minus 3 here, and our LCD, it has got x minus 3 squared, x plus 1 squared. So if we take this x minus 3, only one out of this LCD that we have, what do we remain with? We cancel one of it here, we remain with x minus 3 because there are two of them. So we are going to remain with one of the x minus 3. So we're going to have x minus 3 and also x plus 1. So we are dividing back the denominator to the LCD. What do we remain with? Okay, that is the idea there. So plus the numerator of the second, which is b, we do the division again. So as you can see, x minus 3 squared and x minus 3 squared was going to cancel, and you remain with x plus 1 squared. So here we're going to remain with x plus 1 squared. Okay, plus c, we do the same thing, x plus 1, it divides into this x plus 1 squared. There are two of them, so we're going to remain with the one of the x plus 1. So meaning to say we are going to remain here with x minus 3 squared, and on this x plus 1, we are going to remain with one of it because there were two of them. Okay, x plus 1 squared and x plus 1 squared, it was going to cancel. You remain with x minus 3 squared. So it is going to be plus, all right, so this is C, a bracket there. So it's going to be plus D into, since x plus 1 squared and x1 plus 1 squared canceled, you remain with x minus 3 squared. So that was going to be x minus 3 squared. All right, so that is your partial fractions part. We have to write in a way that we understand here. Once we write in that way, expand properly. After the expansion, now we have to find the values of A, B, C, and D, which are the constants that we have. All right, so the first thing is to target where there are linear, whether they are the brackets, okay, like x minus 3, x plus 1, we target those brackets. Why targeting this? Because if I let this bracket to be equal to 0, it means the whole of this part is equal to 0. If I let x plus 1 to be equal to, it means the whole of this thing is equal to 0. Wherever I see where there's x plus 1, it will be a 0. So that is how we target these linear brackets. All right, so let us start with the bracket of x minus 3. We can see it here. We can also see it here. We can also see it here. We do not have it only on this part. So if we let this bracket of x minus 3 to be equal to 0, it means we have eliminated this part. We have eliminated this part. We have eliminated this part. We are just left with b into x plus 1 squared. All right. So by letting this to be equal to 0, it means x will be equal to what? X will be equal to 3. All right. So if x is equal to 3, let us substitute. We're going to substitute x is equal to 3 here. X is equal to 3 here. All right. So let us have our calculator. Wherever there is x, we're going to substitute on the left-hand side. That is the first thing. All right. So let us have our calculator and see what we're going to have. So on the left-hand side, it's x cubed, which is our x, remember, is 3. So you're going to have 3 cubed, okay, plus 6x, plus 6 times x, or x, which is 3, minus a 7. So this is going to give us 38, all right? So this is the value of that you're going to have here. 38 is equal to, so since I said this is taken at a condition where it was from the bracket of x minus 3, so definitely this is equal to 0. So it means the whole of this part is equal to, like I said, we have eliminated the whole of this part. We have eliminated wherever there's x minus 3, we have eliminated it. So we are going to focus where there is a b, all right? We are going to focus, we have removed it to eliminate, like our elimination method in simultaneous. It's no longer there, all right? So if our x is equal to 3, it is just going to affect on b, because on b, we do not have x minus 3. We have got x plus 1. So we substitute in place of x plus 1 on b, right? What are we going to have? In place of x plus 1 squared, which is on b. That is where I'm saying. So you're going to substitute our x. So it's going to be 3 plus 1 squared, right? Which is 4 squared, which is 16, right? That will be 16. So it's going to be 16b. So meaning to say that here we are going to obtain 16b, all right? If we eliminate, if we substitute x is equal to 3, all that part with x minus 3 will be eliminated. So we are just left with the part where there is b. So we can determine the value of b by dividing. All right, so that's 38 divided by 16. We're going to divide by 16. 38 divided by the answer that we got, that's 19 over 8. So this is going to give us 19 over 8. Okay, so we have the value of b in this case. We do the same thing on the bracket where there is x plus 1. So if we focus with the bracket where there is x plus 1, all right, it means we can find the value of x there. All right, so focusing where there's x plus 1, there's also x plus 1 here. There's also x plus 1. So if we let the bracket of x plus 1 to be equal to 0, it means x is equal to minus 1 at that moment. So wherever you see the bracket of x plus 1, it's now as is. So our x will be minus 1. So you do the same thing, substitute your x, and on the left-hand side, wherever there's x, we have to substitute what? Minus 1. That is what you're given. In this case, we're given that our x is minus 1 by solving x plus 1 is equal to 0. So let us substitute minus 1 cubed. So x is minus 1, so it's going to be minus 1 cubed. Okay, plus 6x. So this is going to be plus 6 times x, which is minus 1 minus a 7. All right, so this is going to give us a negative 14. All right, so a negative 14 on the left-hand side is equal to, remember what I was saying, the whole part where there is x plus 1, it's a 0. So it means the whole function, the whole term becomes a 0. So we are going to focus with a part where we do not have x plus 1, and we do not have x plus 1 on D here. We do not have x plus 1. So we are going to substitute the value of x on D. We're not going to waste our time substituting our values here. We're not going to waste our time. All right. So if this x is minus 1 on this, it's going to be on D. So let us say this is going to be x, which is minus 1. So it's minus 1 minus 3, minus 1 minus 3 squared. Okay. So that's minus 1 minus 3 squared, which is 16. So this is going to give us a 16. So that's, we're going to have 16 what? 16d, because we've got a d there. All right, so divide by 16 both sides. Our d is going to give us what? Which part are we dividing? We're dividing negative 14. So that's negative 14 divided by the answer. This will be negative 7 over 8. So you're going to get negative 7 over 8 as our d. All right, so if we were to take a closer look, we'll see that now we are limited, guys. We no longer have a bracket to equate to 0. We equated x minus 3 in the first place. We said let x minus 3 be equal to 0. Now we move on to x plus 1. Let x plus 1 be equal to 0. We find now we are limited. We no longer have a bracket to equate to 0. So on a condition like that, what do? You expand the given expressions that you have so that you can be able to equate the coefficients of equivalent expressions of expressions which are the same. So we have to expand we are forced to expand everything. So this is one of the stages that is boring in our N6 to say we have got something that is just direct, but instead of giving us something that is direct, they want you to do the expansion. So this is what I'm trying to say. All right, x cubed, expand. So here we're going to expand the brackets, expand brackets, and equate the coefficients, and equate the coefficients. So these are coefficients of equivalent terms. Equivalent, that is same terms, all right? The terms that are the same or the terms that are equal, you equate them. So this here is going to be x cubed plus 6x as it is. This one is just going to remain as it is. It's already in an expanded manner, so there's nothing that we have to expand here. But we have to expand now the other side. So if we expand properly here, what are you going to have, guys? I think this part you now have, so I'm just going to use this part, all right? So let me remove this part so that we can use it for our expansion. So you were supposed to expand each separately aside. You just separate this aside. Okay, sorry for that. Sorry for that, guys. I forgot. I need the value of b and this values. Let me. Okay, no problem. I'm just going to expand here. Let me expand here. So this is where we are going to expand the part of a into the bracket of a. So it's going to be a into the bracket of this. So it's going to be ax. Let's multiply the first bracket, all right, with a. So it's going to be ax, all right. A times minus 3 is going to be minus 3a, okay, into the bracket x plus 1 squared. Remember that algebraic expansion. So it is going to give us first term squared, which is x squared, plus 2ab, which is 2 times x times 1, which is 2x plus 1. You expand this, all right. Then after, gonna multiply everything by ax. So I mean by ax in the second bracket. So it's ax times, all right, ax here times x squared. So this will be ax to the exponent of 3, okay? Then we move on, ax times 2. So it's going to be plus 2a, all right, 2ax squared, all right, 2ax squared, we multiply. Then we move on, ax times 1. So it's going to be ax. So that's plus ax. We are done with this. We move on to negative 3a. So negative 3a is going to multiply everything in the second bracket. Negative 3a times x squared, that will be negative 3ax squared. All right. Negative 3a times this is going to be negative 6ax. Okay. Negative 3a and positive 1, that will be a negative 3a. All right. So we've expanded this. So in actual sense, if you know how to expand in a way that is direct, guys, there's no need for you to actually do this, like, but you have to show this because there's no way, like, but unless you are that someone who can trace, okay, if I expand this, it's going to be x cubed. But in most cases, most of us, we have a challenge in doing that. So to avoid that, just expand properly. All right. Then we are done with this part of A. We move on to the part of B. All right, so let's move on to B. So for B, we're just going to expand. Remember, x plus 1 squared, we expanded this. We said it's the same as x squared plus 2x plus 1. But it's going to be multiplied by B, which is outside. So it's B times this, which is going to be x squared, b times 2x, which is going to be plus 2bx, b times 1, which is going to be plus b. All right, we are done on this part of B. Let us move on to C. So on the part of C, we also have the expansion of x minus 3 squared there, x minus 3 squared. So if we use the formula of a minus b squared, which we said it gives us a squared minus 2ab plus b squared. This will be x squared, which is the first term. So it's going to be x squared minus 2ab. So it's going to be minus 2 times x times 3, which is minus 6, right? Minus 6x plus b squared, which is 3 squared, which is a 9, all right? So this is the expansion of the bracket of x minus what? Of x minus 3 squared. That is the expansion. But if we take a closer look, there is a c there, and there is a bracket of x plus 1. So if we multiply c into the bracket of x plus 1, we are going to have cx plus c times 1, which is c. So we expand. Yes, you can expand first the brackets, then you multiply by c later on. It's fine. It's fine. I'm not saying it's wrong. All right. So at this stage now we can expand. C is already affected everything in this bracket. So it is going to also affect everything in this bracket. All right. So that's cx times what? Times x squared. So it's going to be plus cx cubed, x and x squared, that's x cubed, okay? Cx and minus 6, that will be minus 6c x squared. X and x gives us x squared. Cx and 9, that will be plus 9cx, okay? C multiplies x squared, so it's going to be plus cx squared. C multiplies minus 6x, so it's going to be minus 6cx. It multiplies x minus 6x, so it's going to be minus 6cx. C multiplies 9, so that will be plus 9c. Okay, so we are done on this expansion of the C. We move on to D. All right, we expanded this part of x minus 3 squared, guys. We got x squared minus, remember it was 6x plus 9. So here we're just multiplying by D, which is out of the bracket, right? So let us multiply by D. So this will be D times this, which will be plus dx squared. D times this, which is going to be minus 6dx, okay? D times this, which is going to be plus 9d. We have expanded everything by what? By D. So at the end, it means we have managed to expand each and every bracket that we were given here up to the point of D. We have expanded everything. So what is the purpose? Like I said, the purpose of expanding is that we'll be able to equate here, expand the brackets and equate the coefficients. So we're going to equate the coefficients of the equivalent terms. So what am I trying to say when I'm saying equivalent terms? If you check on the left-hand side here, this is what we have. On the left-hand side, we've got x cubed plus 6x minus 7. So if we are to take that, what is on the left-hand side, and we equate the coefficients of x cubed, you work with the coefficients of x cubed. The coefficients, I'm saying the number that is affecting x cubed there, that is the coefficient. So you have to equate those coefficients. So on the left-hand side on x cubed, there is a 1. Okay, the coefficient of x cubed, it's a 1. It must be equal to all the combination of the coefficients of x cubed on the right-hand side. Remember the concept. So you equate to everything on the right-hand side. All right, so let's figure out where there is x cubed on the right-hand side. There is x cubed here. What is the coefficient? The coefficient there is it's a. So you're going to take a on your answer. So this is equal to a. Let us check for another x cubed. So x cubed, let's check for another x cubed. If you check properly, you're going to see that there is another x cubed there on cx cubed there. So what is the coefficient of x cubed there? That's a c, and it's a plus. So you're going to take the coefficient, which is plus c. All right, let's move on and see if we still have another. We do not have. So that is the only part that we have up to the last term. That is, yes, we can combine those ones of x squared if you want, but yeah, guys, because of time, we're just going to equate them as they are. So meaning to say, for the coefficients of x cubed, this is what we have. 1 is equal to a plus c. But do we have any of these? We do not have a, we do not have c. So this equation is useless for now. We do not have a or if it was b plus c, you substitute b, but we do not have a and c. So just leave it like that. Okay, move on to another part. All right, so we're gonna work this time with the coefficients of x squared. All right. Let's try x squared and c. So it's not like you know the answer where it is. Here, there's no answer, but you use this equation. You have formed it, leave it like that. You see what's going to happen. So on the left-hand side, we do not have x squared. Remember, it is supposed to be, the cubic function is supposed to be in the form of ax cubed plus bx squared plus cx plus d. This is the format, ax cubed. It is supposed to be followed by x squared. So the part of x squared is not there. So it means it was 0x squared. So the coefficient of x squared, since it is not given, it's what? It's a 0. All right. So that means here we're going to have 0 is equal to, we take all the coefficients of x squared on the right-hand side. All right. So let us check on the right-hand side where there is x squared. Remember, here there's x squared. What is the coefficient there? It's 2a. So this will be equal to 2a. We also have x squared here. What is the coefficient? Minus 3a. So this will be minus 3a. This way, we are supposed to have simplified these numbers, but because I said I will simplify later on, but we're supposed to have simplified this before. That's why you see 2a and minus a there. Okay, no problem. We are still on the coefficient of what? X squared. We are on x squared here. There's a b, so it's going to be plus b there. There's a b here. All right, x squared. We have to check where there's x squared. There's also x squared here. What is the coefficient? Minus 6c. So there is a minus 6c there. All right. Okay. Is it the only part? Okay. All right. We also have x squared here, which is a plus c. All right. Do we have another? Okay, and also a d here, and also on an x squared, there's also a d there. So it's plus c plus d. That is the only part here. So we've got, remember, we've got two things here, c and a d. So you're gonna add plus c plus a d. All right, plus c plus a d like this. So these are the coefficients of x squared. Let us see what you're going to formulate. 0 is equal to 2a minus a, that will be minus a. B minus 6, that will be minus, oh, hey guys, what am I trying to do? This is impossible. So B is just going to remain as it is. Minus 6c plus a c is going to be minus 5c, okay? Plus a d, like this. So we have formed another equation again here. All right. But this equation, it consists of b and d. So if you check properly, instead of us going back and equate the coefficients of x, equate the constants, is going to be too much. What I want you to see is something here. I want you to see with what we got here. On top, we have calculated b and d, all right? We have calculated b and d, this one, b and d. We have got b here. We also have a d, so we can substitute. Here it was an equation in terms of a and c. So it means if you substitute b and c, you are going to be left with an equation with what? With a and c. So that means you are going to be left with a simultaneous equation. So instead of you expanding again, yes, you can do that, but guys, it's going to be too much. So this is it. Let us work with the second one. So I'm just going to take this part here from this part, all right? From these coefficients, let us substitute. Okay, let us just say this is equation 1. This is equation 2. So from equation 2, I'm going to substitute the values that you are given. So 0 is equal to minus a, there's nothing there, plus b. We got b as 19 over 8. So it's going to be 19 over 8 minus 5c plus d. Our d is negative 7 over 8. So it will be plus minus, which is minus 7 over 8 like this. Okay. Let us simplify the left-hand side, the right-hand side first before we transpose, because these numbers can be added or simplified together. So 0 is equal to, as you can see, we are left with minus a, we are left with minus 5c. So it's going to be minus a minus 5c. Combine the numbers together, okay? Let's see what you're going to have there. Like I said here, you're going to formulate simultaneous equations. So it's a nice question, actually, this one. All right, 19 over 8. All right, you're going to subtract 7 over 8, 7 over 8 like this. That will be 3 over 2. Okay, why are we having this? Okay, no problem. Let us just use it like that. So this will be 3 over 2 here, positive 3 over 2. I just hope we're going to get like a whole number. That is what I was expecting. All right, of which it's not a problem. So this is what I'm going to do depending with how you want to solve your equations, all right? But as you can see, now we have got simultaneous equations that are easier for us to solve. We have got A and C here. We also have A and C, so it depends. We can make A the subject here from the equation 1. I can make A the subject. That will be 1 minus C is equal to A, or let me just do this way. 1 minus c is equal to, the solving part is in your hands. I don't know how you want to use elimination method, you want to use substitution method. Okay, so using substitution method, if I let a to be equal to 1 minus c like this, also I transpose for a this side, I transpose a this side, it goes this side, it becomes a positive. So it's gonna be a is equal to minus 5c plus 3 over 2. So if this represents a, which is minus 5c plus 3 over 2, if this represents a, and also this represents a, which is 1 minus c, what does it mean? It means these two are equal. So we can equate these two. That's an equation. So I'm just going to equate 1 minus c is equal to minus 5c plus 3 over 2. It's an equation so that I can solve for c. So from this one, we are going to solve for c. Okay, so the solving here, in order for you to solve, guys, go back to your N3 stuff, all right? Revise your small, in fact, N2, yeah, revise your N2 stuff so that you'll be able to choose. I'm not saying follow this, no. The idea here is done. What I wanted you to understand here is done, to say, how do you calculate, like, how do you work out to, in order for you, but in order for you to have these equations. But after you have these equations, the simplification is in your hands. Okay, so this is where we are now. So at this stage, you can solve for c transpose minus 5c this side. We're going to transpose also 1 that side. So this will be minus 1 plus 5, that will be 4. That will be 4c is equal to, if we take 1 that side, it will be minus 1 this side. So 3 over 2 minus 1, that's what? 1 over 2. So this will be 1 over 2. So to find c, we have to divide by 4. So it's 1 over 2 divided by 4, right? Of which you can just do that on your calculator, but that will be 1 over 8. That's so, yeah, 1 over 8. 1 over 2 like this, divided by 4. So if we divide this by 4, we are going to get 1 over 8. So our c is going to give us 1 over 8. All right, so if our c is 1 over 8, what about a? To find a, is either you are going to substitute into this equation from our first equation here. We can substitute here because a is already the subject, or you can substitute in the second equation. So I'm going to take the first one because it's easier, this one, guys, to use. As you can see, guys, there it's easier. A is equal to 1 minus c. So if a is equal to 1 minus c, it's going to be 1 minus 1 over 8. So a is going to be 7 over 8. That's 8 over 8 minus 1 over 8. So it's going to be 7 over 8. So we have all the values A, B, C, and D. All right, so we have got our A, our B here, C, and D. All right, all the values are there. Once you have these values now, so this is your partial fraction. Your partial fraction was to apply your partial fraction like this, guys. You apply your partial fraction in the process of solving this and that. We've solved that. We have your A, B, and C, and D. After that, we go back to the topic. The topic is not on partial fraction. The topic is on integration. So you're supposed to go back now, substitute those values of A, B, C, and D so that we'll be able to integrate, because it was an integral of this. So this whole integral was supposed to be equivalent to this presentation that we have here, this presentation that we have. So from this presentation, we are going to have this as the integral of, all right? So I'm just going to write it aside here. So therefore, we're going to have the integral, all right? We're going to have the integral of a over, the first part, it's a over x minus 3. Our a there is what? Our a, we got, that was 7 over 8. Yeah, 7 over 8. So it's going to be 7 over 8 here in place of a. So it's supposed to be a over x minus 3. Take note, a over x minus 3. So how do you write this? You can write it like this, 7 over 8 out of the integral sign, right? It's supposed to be a, which is a constant. So you can write 7. So therefore, we're going to have this as, guys, let me just write is equal to, because here, guys, I'm now like, I didn't want to present this way. So let me just write is equal to. So remember, our a is 7 over 8. So if I take 7 over 8 out, I'm going to remain with what? With 1 here. So it's going to be 1 over x minus 3. Okay. Plus b, our b is 19 over 8. 19 over 8. So you're going to take that 19 over 8 out. So it's going to be plus b, this one. All right. So instead, let us integrate each separately because now we have what each. So you're going to separate this plus b, remember, is 19 over 8. So it's going to be plus 19 over 8, the integral of, if we remove this b because we've taken it outside of the integral, we remain with a 1. So it's going to be 1 over x minus 3 squared, like this, okay? C over x plus 1, we have to check for c. So let us check for c. Remember our c here, we got our c as, it was a negative, positive 1 over 8. So that was positive 1 over 8. So it's c, which is 1 over 8. But here it's c over x plus 1, c over x plus 1, all right? So we're going to have this as plus c, which is, we got 1 over 8, so it's 1 over 8 into the integral of 1 over x plus 1. It was c over x plus 1, so it's going to be 1 over x plus 1 with respect to x, all right? Then we move on to the last one, which is d. So d, in this case, it was negative 7 over 8. That is our d, negative 7 over 8. So it will be, the sign is supposed to be involved there, negative 7 over 8, the integral of what? It's d over what? All right, this is d over x plus 1 squared, d over x. So if we remove this d out, you remain with 1. So it will be 1 over x plus 1 squared. So here it's going to be 1 over x plus 1 squared, like this, with respect to x. So this is what you are now supposed to integrate. So forget about this now. Forget about this, that we were doing our partial fractions. We applied this. Yes, it was important that you know your partial fractions. And there's no way you can even work out without knowing this. You have to know this. So after having your partial fractions, they are now in an expanded manner. You introduce your integration back now. You have to integrate this. So how are we going to integrate these fractions that we are given here? All right, let us start with the first one. From our integral, we know 1 over gives us a ln. If it is a linear like this, it is going to be a ln. We are going to get a ln. So that will be 7 over 8, the ln of x minus 3. All right, but now here it is going to be something else because we are given this here as x minus 3 squared. It's no longer a linear expression. So how do I integrate this? I was supposed to actually use substitution. Remember from your substitution method, the integral of 1 over x minus 1 over x minus 3, like this, can be written as 1 over u squared. All right, this can be written as 1 over u squared if we let u to be equal to x minus 3. And if we check here, the derivative of u with respect to x is going to be 1. So it means du is equal to dx. So this will be just a du. That is the important part of this. So meaning to say we are integrating u to the exponent of minus 2. 1 over this is to the exponent of negative 2 with respect to u. So we can integrate now. Remember the integral, we add the exponent. So it's going to be u to the exponent of minus 1 over minus 1, which is minus 1 over u. Okay, we take this u to the exponent of minus 1, it's 1 over u, but there's a negative there, so it's going to be minus 1 over u, which is simply minus 1 over u. Remember, u is what? It's x minus 3. So meaning to say, to integrate this, we are going to get minus 1 over x minus 3. This is what you're going to have, plus 19 over 8 in this part, multiplied to the integral. We have integrated this part. We got minus 1 over x minus 3. So this is what we are getting. So Is there not any other way that we could have integrated in an easier way? Okay, it follows that the integral of this nature, if you write it as an exponent, if you write it to the exponent of a certain term like that, this one, x minus 3 to the exponent of minus 2 like this with respect to x. What you do is that you integrate your bracket as it is. So this will be x minus 3 to the exponent. We add 1, so the exponent of -1 over -1 times the derivative of what is inside of the bracket. So the derivative of x is a 1. So it does not affect our solution, this one. So still we could have integrated direct. We're going to still have the same thing, -1 over the bracket of what? Of x minus 3, which is the same that we have here. All right. So that is how we can integrate. Guys, let us consider our N5. It's still in existence. Everything that we did in N5, it still has to be applied. Okay, plus 1 over 8 at this stage, we integrate. So this is same, it's a linear just like this. So it's going to be ln. So it will be ln of x plus 1. But if there was a certain expression, let's say it's 1 over 2x plus 1, you find the derivative of this, which will be 2. So instead of you just, it's going to be 1 over 2 ln x plus ln 2x plus like that. So it's 1 over the derivative. So it's not like you are just supposed to just write ln each and the no. There it was just direct because here the coefficient of x, it's what? It's a 1. So it's just ln x plus 1. Okay. We do the same thing on our substitution on this part of the part of 1 over x plus 1 squared. So we are supposed to apply the same substitution just like what we did on this part. But remember what I explained is that you can do this in a shorter way. If you can write this as the integral of x plus 1 to the exponent of -2 with respect to x. You integrate the bracket as it is x plus 1 to the exponent. We add 1 on the exponent, so it's going to be -1 over the new exponent. But you have to multiply by the derivative of what is inside of the bracket. And if we differentiate this, we're going to get a 1. The derivative of x is a 1. The derivative of 1 is a 0. So meaning to say, this at the end was going to give us -1. This negative, remember, right? Negative on top. So it's -1 over x plus 1. This exponent, we take it down to the denominator. So meaning we were going to have -1 over the bracket of x plus 1 like this, plus the constant of integration. We are done. We do not have anything to integrate. So that is how you integrate these fractions. All right. So at this stage, we can just simplify our answer to be in simplest form. So therefore, our final answer here was going to be equal to 7 over 8, the ln of x minus 3 plus, all right, so here we're going to even multiply. Positive, negative is going to be a negative. So it is going to be minus, multiply 19 times 1. So it's going to be minus 19 over 8 into the bracket of x minus 3. Numerator times numerator, okay? Plus 1 over 8, the ln of x plus 1. All right, the same thing, numerator times numerator, -7 times -1 is going to be a positive 7 over 8 into the bracket of x over 8 times x plus 1. Multiplying denominator to the denominator plus the constant of integration. So if it's not like your answer is supposed to have exactly this order that you are seeing, your answer is supposed to carry these terms. If your answer carries these terms, if you can see this term on your answer, you see this term on your answer, you see this term on your answer, you see this term on your answer, it means your answer is correct. Not the order. The order does not matter because I do not know how did you expand in terms of order. Maybe you started with squared followed by 1, squared followed by 1, or you start by 1 going to the squared. It's one and the same thing. You can start if it is like for a repeated linear, when you are doing the by part, when you are doing your partial fractions, I mean, you can start with the highest exponent, which is what? Which is 2 up to 1. You can start with 1, 2. If the exponent is 3, you can start with 3, 3, 2, 1, or you can start with 1, 2, up to 3. So the order on how you do it, it's up to you. It's in your hands. That order on how to do it, the order on its own, it's in your hands. It's in your hands. Okay, so that is how we could have done this question. So like I said, if you check here, the most important part is, do you know how to apply your partial fractions? And it's a lot, as you can see. You need energy, like I always say, for N6, you need a lot of energy. There is no way, guys, you need as you can see, guys, like it will be just a repetition of something. Like you'll be wondering, why am I doing this? Because it's one thing that I'm just writing, and it will be like that in exam. So we just hope when we write our finals, we just have a question which is easier to express into partial fractions. All right, so that was the first part. That was the first part, and don't forget your solution here. At the end, this was now our integration. At the end, like I said, you are supposed to now integrate whatever that you had from those partial fractions now to integrate. All right, so that was the first part. And we're going to check the second part here. Let us try to have. So always you must bear in mind everything that I was saying about partial fractions, the order of the partial fraction, this and that. All right, so let me, sorry guys. Okay, let me just remove this because it's now affecting me here. All right, yeah, like this. So like I was saying, you have to know everything from the order up to the last part, to the integral up to the last part. All right. So let us check this one and see 3.2. Okay. We are given to integrate x squared, all right, over, so this is over 1 minus x, all right, 1 minus x into x squared plus 1. All right, this is x squared plus 1 with respect to x. Okay, so this is what we have. And I said the first thing is to think of having our partial fraction so that we'll be able to integrate this. Okay, so if we check, we saw that we have got this of a linear x squared plus 1, which is a quadratic. This cannot be factorized. So we said any quadratic should be written in the form of ax plus b, all right, over that quadratic, which is ax squared plus bx plus c. Remember the format. So meaning to say, if I choose to start with this as a, okay, if I let this x squared over 1 minus x into the bracket of x squared plus 1 be equal to, it's going to be 1, or it's going to be a over the first bracket. It's a linear term. It's a linear bracket, that one. So it's just going to be a over 1 minus x. So since we have used this a, it's no longer possible for us to also write this for the quadratic and say ax, because already we have exhausted this a. So you move on to the next term. So this will be b, and this will be the next term, which is c. So it's going to be bx plus c, not this one, but it's going to be bx plus c. So you're supposed to be careful on that one. Bx plus the next term, c, over the quadratic. So this ax squared plus bx plus c, this one is the format of the quadratic, which is the one that you're given. So there we are given the quadratic, which is x squared, the one that cannot be factorized. Remember, I said this formula is used only if you are given a quadratic that cannot be factorized. For any linear, you work with this format of a linear, a over that term, but quadratic, it's bx, it's always x plus. There's going to be a term times a constant times x plus a constant. That is how you expand for a quadratic that cannot be factorized, all right, as long it cannot be factorized. So meaning to say, we can now equate. Remember, I said once at this stage, you're going to equate the numerators, all right? So from the left-hand side, our numerator is x squared is equal to, here we've got a into, we cancel 1 minus x and 1 minus x was going to cancel, which means we're going to remain with x squared plus 1. So this will be bracket of x squared plus 1. All right, plus the numerator here, which is bx plus c. So there we have got bx plus c. This was going to cancel x squared plus 1. X squared plus 1 was going to cancel, meaning to say you were going to remain with 1 minus x. So you're going to multiply with 1 minus x like that. Okay, I hope this stage now you understand it. So at this stage, we can see that here we got a quadratic and there's no way we can have x. We can't determine the value of x. So we can't let this bracket to be equal to 0, because if you say x squared plus 1 is equal to 0, x squared will be equal to minus 1. And we can't determine the square root of minus 1. So we are limited on this one because it's now giving us complex numbers. We move on to this bracket. It's a linear, so we can at least work with that one first. It's a linear, so we can let that bracket to be equal to 0. All right. So let us let the bracket of x minus 1 minus x to be equal to 0. So if we let 1 minus x to be equal to 0, what it means is that 1 will be equal to x if we transpose x to that side. So 1 will be equal to x. So simply meaning that x is equal to 1. So when x is equal to 1, substitute 1 here. We're going to have 1 squared, and 1 squared is 1. We substitute 1 here, 1 squared. That's a 1 is equal to. Since we are focusing on this part, it means the whole of this part is now a 0, because we said 1 minus x is a 0. So the whole of this is going to be, was 0 times anything gives us a 0. So we are only focusing on where there is an a. So you're going to substitute a 1 here. So this will be 1 squared, which is 1, plus 1, which is 2. So that's 2 times a, which is a 2, right? The 2 times a, which is 2a. Okay. So we can find a divided by 2 both sides. So a is going to be 1 over 2. All right. We saw this properly, and we saw it that we cannot even work with the bracket of x plus 1 squared. So meaning to say, for this thing of letting this bracket or letting this number to be equal to this, or we are done. We can't use it anymore because x plus 1 squared, we can't find any value of x there. So what do? We are back to that expansion of brackets again. So we are going to expand brackets, equate the coefficients. So let us expand the brackets. All right. So in this case, if we expand the brackets, we have to equate the coefficients of what will be corresponding. So the left-hand side, there's nothing to be expanded there. It is just x squared. So x squared is equal to, expand this by a. So a is going to multiply everything. So multiply everything by a times x squared, which is going to be ax squared, a times 1, which is going to be a. All right. You move on to the second part, we multiply, expand everything, start by bx, so it's bx times 1. So this is going to give us bx times minus x. So this will be minus bx squared. Okay, we are done with the bx. We move on to c. So it's c times 1, which is going to be plus c. Okay, then we expand c and minus x. So this will be minus cx like this. Okay, we have expanded everything. So we equate the coefficients. Let us start with x squared. So on the coefficients of x squared, all right? So for the coefficients of x squared, all right? The coefficient is what is affecting that number. That is what I'm saying. That term, the term x squared, what is affecting x squared is 1. So 1 is the coefficient of x squared. On the left-hand side, we've got 1. So 1 is equal to. On the right-hand side of our equation, what are the coefficients of x squared? There is a here on x squared. So we've got a here. On x squared, there is a minus b. So it's a minus b. So this one is an advantage. It's not like the previous question that we had where we form an equation, we form another one. Here we can solve for b because we have the value of a. We calculated that before. So 1 is equal to a, which is a half, minus a b. So to find b, what are we going to do? We can transpose b to this side. It becomes a positive. So it's going to be 1. Then transpose 1 to this side. It becomes a negative. So that's b is going to be minus a half. All right, we have the value of b. Well, let's move on to the other coefficients. Here we equated the coefficients of x squared. So we are going to move to another one. Let's say we equate the coefficients of x. Where there is x, only where there is x. Do we have x on this side? We do not have x. This is a quadratic, so it was supposed to be in the form of ax squared plus bx plus c, a quadratic. So we do not have x, so it means the coefficient of x there was a 0. It's not there. Okay? The coefficient of x, it's not there. But on the right-hand side, we have x there on the right-hand side. There is x here. What is the coefficient of x? B, and it's a plus. So this is going to be b. We move on. Do we have any other coefficient of x? Yes, there's another x here. The coefficient of x there is what? Minus c. So that will be b minus c. And we have the value of b. We calculated b. Our b is negative half. So it means 0 is equal to minus a half minus c. So it means c taken this side, it becomes a positive. So c is equal to minus a half. Okay, so we have the value of a, we have the value of b, we have the value of c. All the values are there, the ones that we need in this part of our partial fractions. All right. So meaning to say, if we substitute this, we are going to have this as, so this whole part will be equal to, all right. So a is 1/2. So this is a here, which is 1/2. Take note, a 1/2 on top there. So it's going to be 1/2 over x plus 1. All right. Is it x plus 1 there? 1/2 over 1 minus x. Sorry, that's 1 minus x. So it's going to be 1 minus x. Let me just write it this way. I'm going to explain later on. Okay. Then our b, it's a half. So it's going to be plus b there, plus bx. So it's plus bx, and our bx is a negative half. So it's going to be negative half of x, okay, plus c. So this is bx plus c, all right? Our c, it's a minus half. So this will be minus a half like this. Everything over what? Everything over x squared plus 1. So this is exactly what we were supposed to have in a normal sense. But we are supposed to perform an integration. Remember, this whole thing was being taken from the integral of this. So we are supposed to integrate this with respect to x. And how are we going to integrate this with respect to x? How are we going to integrate? Okay, so let us start with the first part here. We can take out the half, which is this on the numerator. It is not affecting anything, so you can take it out of the integral. So it's going to be half the integral of 1 over 1 minus x, okay, with respect to x. We do the same thing. There is a minus half x here and a minus half, okay? There is a minus half and a minus half, which is common. So we can factor out the minus half out of the integral. If we factor out this minus half here, what do we remain with, all right? So let's say we have performed our factorization. There is a minus half x, there is a minus half here. So we have taken this minus half out of the integral. What is going to remain here? We are going to remain with x minus 1. If we factor out, it's going to be x minus 1, okay? Everything over x squared plus 1 like this with respect to x. So this is what you're supposed to have in normal sense. All right. Of which, as if it's not enough. So on this integral, we can work with this as it is as 1 minus x, or we can change this to be x minus 1, or you leave it like that. Okay. But here, in order for you to integrate, it's going to be difficult for us to integrate. So I want us to get back to our N3. There is this part that we always talked about on fractions. A plus b over c can be written as a over c plus b over c. So we have a numerator here divided to x squared plus 1, which is x and minus 1, can be separated as a and b like that. So meaning to say, we can even separate this integral so that at least we can be able to integrate properly. So this will be a half. Let us just leave it like that. We are not yet integrating. We're just separating minus half, minus x here, dx. So that will be minus a half. So we are going to have minus a half times the integral of a over c, of which our a there is x, over c, which is x squared plus 1. So it's going to be x over x squared plus 1. All right. Here we are supposed to have a minus half, which is going to multiply a minus 1. So instead, it's going to be a positive half. So that will be a positive half. So this is with respect to x. So it's going to be a positive half, the integral of 1 over x squared plus 1 with respect to x. So take note, it was supposed to be minus 1. So the minus and the minus for the half gives us what? A positive. So at this stage, at least we can be able to integrate each. Let us integrate each here. Remember, I said we can integrate a ln, but in a 1 over a certain linear expression like that. It's 1 over x, 1 minus x. It's a linear. So I said in order for you to be able to integrate this, you find the integral, you introduce ln. So it's going to be ln of the ln of 1 minus x. But since there is 1 minus x, you have to divide by the derivative. The last part, it was clear because it was like x plus 1. So with the derivative of x, there was just a normal part, which is just 1. But here there's a negative, that we have negative x. So it means it affects also our derivative, all right? So we're going to divide by the derivative of the f of x here, the derivative of x here, which is minus x. So what is the derivative of minus x? It's minus 1. So you divide by minus 1. Take note, okay? Ln, but you have to divide by. You have to divide by the derivative of x, okay? Minus a half in this case. How are we going to integrate x squared plus x squared, x over x squared plus 1? This part, how are we going to integrate with respect to x? All right, there we can have our substitution. Okay, let us put this aside like this. We want to integrate x over x squared plus 1. So there's something happening here with respect. If we let this to be u, it means it can cancel this x on top. Is that so? Yes, it can cancel. So let us use substitution method here. So let u be equal to x squared plus 1. The derivative of u with respect to x is going to be 2x. That means dx, if we make dx the subject, is going to be du over 2x. Remember your algebraic substitution from your N5, guys. So this will be, it was supposed to be the integral of x over u. Remember, x squared is now x squared plus 1 is now represented by u times du dx, this part of dx represented as du over 2x. So it's going to be du over 2x like this. So that's why I'm saying the x and the x was going to cancel. So you're going to take 1 over 2 out of the integral. So it's going to be 1 over 2, the integral of 1 over u with respect to u. And we have been talking about this integral of 1 over u. It gives us what? A ln. So it's going to be ln u. And our u is represented by what? By x squared. So it's going to be 1 over 2, the ln of x squared plus 1. So meaning to say here, if we integrate this, remember we were integrating this x over x squared plus 1. And this is what we have after integrating a half. So meaning to say here, the answer that we have already, there was a minus half out of the integral. So we are going to multiply our answer by that negative half. So it's going to be 1 over 2, the ln of x squared plus 1, like this. Okay, so that's, this one is direct. Okay, then we move on to the integral of this 1 over this. All right, let's remove this and see. So you're going to check the integral of, so you got plus 1 over 2. I closed the bracket for ln. I'm supposed to close the first bracket. All right, so this is plus 1 over 2. We integrate 1 over x squared plus 1. So how do we integrate this? So on the integral of this 1 over x squared plus 1, substitution is not going to work, because if I let this, it was going to give us 2, and that 2x has got nothing to cancel, because by a substitution, remember from your N5, it must cancel with something so that you do not remain with x. But if you want to use it, you remain with x. So it's impossible for you to simplify further. So substitution is invalid. So what do you do? Okay, I want you to take a closer look on your formula sheet. You're supposed to know this, but I'm going to explain it from the formula sheet. It was the inverse that we had of the tan. All right. If you take a closer look here, we've got the integral of this, the integral of a squared b plus b squared x squared is equal to 1 over b arctan bx over a, this one. Okay, let me write this integral so that we'll be together. I'm just going to write it aside here. From this integral, it states that if we are given to integrate dx like this over a squared, all right, it was given in terms of a squared. All right, I want something that has got x, only x, like x. All right, it's still fine. We can write it in that way, but it's what it was given as a squared, no problem. I'm just going to write it the way that we are given there. It was a squared plus b squared x squared like this, which is equal to 1 over ab arctan bx over a. So like I said, we are supposed to know this integral, that it was taken from arctan. But if you do not know this, then you check for the format of this nature. So this is supposed to be written as the integral of 1 times dx is just same as dx, right? Over, in order for us to have this format, it's a constant. A squared is a constant. So we're just going to start with a constant, which is 1. So it's going to be 1 squared plus x squared. But we're supposed to have b squared. So we do not have b. So just going to be 1 squared x squared like this. So b is just a 1. So this is your a, this is your b, this is your x. So that's a, b, x. So that if you substitute here, it simply means 1 over ab. And what is our a? Our a is 1, our b. So that's why I'm saying if it is a 1 like this, it does not affect, all right? So that's a 1 here. Then we're going to have arctan of bx. Our b is also 1. So it's going to be 1 times x over a. Our a is also a 1. So that was just going to be arctan of what? Of x. So if you know the derivative of arctan, you are not supposed to do all this. You know that the reverse of a derivative is the integral. If I know that the derivative with respect to x of arctan x is equal to 1 over 1 plus x squared like this. So it means if I integrate this, I'm supposed to go back here. So that's why I say this formula was not even necessary. But if you do not understand your derivative integration exchange, therefore go back to the formula, use the formula, this one, you still get the same answer. You are not limited for N6, all right? So this will be 1 over 2. We say the answer there is arctan. So you're going to have arctan of what? Arctan of x, then plus the constant of integration. We are done. So that's it. That is how we are supposed to apply the formula, or just to know this from your basics derivatives. So there we can just simplify further. We are done. The -1 multiplies with the half is going to be -half the ln of 1 minus x. So this will be ln of 1 minus x. Minus half times a half is going to be -1 over 4. So it's going to be -1 over 4. The ln of x squared plus 1. All right, this one is already in simplest form, plus a half arctan of x. So it's plus a half arctan of what? Arctan of x. So that is how we're supposed to have attempted this question. We have to be very, very careful in our simplification, the approach that we are going to have in a later stage, the approach that we're gonna have. How are we going to simplify our given questions? All right, our given questions. How are we going to simplify them? All right, there's something here, guys. All right. I mistakenly separated here. Remember, this was a negative. Okay, guys. All right, let me check here. This was a -half, the one that we factored out. Oh, guys, this was going to be a positive. This is mistake. I have mistaken everything here. This was going to be a positive here if you factor out a -half. this was going to be a positive. So I hope someone saw this. Okay, so it means here, if this factored out to be a positive, when you now multiply by this negative half, it was going to be negative. Then negative here is going to be a negative here. Guys, sorry for this, guys. I'm very, very sorry here. So it was going to be a negative here because we have now multiplied negative, positive, gives us a negative. All right. In actual sense, we're not even supposed to expand that. We're just supposed to expand direct. You see, this thing of expanding stage by stage, it affects now, like expanding without doing it stage by stage. It affects, you see now what I ended up doing. So all this is just a negative here. Okay, so let me check also here. Okay, that's it. So if you've got any other part that you see which is not clear, let me know, guys, on the comment section so that you can work on that. But I think that was the only part checking with the work that I did on my preparation. I'm seeing this is not corresponding. Why is it not corresponding? The rest there is fine. So this is how you play around with these questions of integrations and so forth, partial fractions. Like I said, guys, N6 is a lot of things. You just have to take your time as an individual, try to do at least 1 or 2 questions and see how do they ask those questions, all right? So we just hope to work with more questions in our revisions as we are preparing for exams ahead of time, as we are preparing for these exams that are ahead of time. So we shall see in our next class working with the other questions from other question papers also.